Now we're at the bottom of page 72 and we're going to go to the top of page 76. So in the prior videos we have focused on the entropy, the total entropy or entropy of the universe, and last video we focused on the entropy of the system. Well, now we'll look at the entropy changes for the surroundings. So a process we are considering in the system will affect the order in the surroundings by the exchange of heat. So I kind of put a star by this. The only thing we analyze to determine the sign of the delta S of the surroundings is the heat flow. So if you have a positive delta S of surroundings, it means heat is flowing into the surroundings. But if you have a negative delta S of surroundings, then heat is flowing away from the surroundings or out of it. So here's a note card that we can look at, and your delta S of surroundings is going to be positive if you have heat flowing from the system into the surroundings. And your delta S of the surroundings will be negative if you have heat flowing from the surroundings into the system. So I think of it as if I have heat flowing into the surroundings, then the molecules of the surroundings are going to start moving faster and they're going to get more disorderly. But if you're removing heat from the surroundings, they're getting colder, and so they'll start moving in a more orderly fashion, and so the entropy becomes less. Here are a couple examples that I came up with separate from the note set. So let's consider this. If I have some ice that's melting, it's changing from a solid to a liquid, what would be the sign of the delta S of this system? Well, it's becoming more disorganized or disorderly as it changes from a solid phase to a liquid phase, so this has a positive delta S of the system. However, the process of melting, in order to figure out our delta S of surroundings, we need to know what is the heat flow like between the system and the surroundings. Melting is an endothermic process. The solid has to absorb heat in order to melt and become a liquid. So the heat must be flowing from the surroundings into the system in order to make the solid melt and become a liquid. And so because we're taking heat away from the surroundings, then that means we have a negative delta S of surroundings. What about the delta S total? Well, remember, melting is going to be a phase change, which means this system is at equilibrium, and so that means that we have a delta S total that's equal to 0. Here's another example. So let's say we have dissolving, and I have this salt, metal and non-metal, and it's a solid, and then we place it in water and it dissolves and becomes 2 aqueous ions. So if I were just to analyze the system, would I say that the system is getting a greater or a lower entropy? And I would say that the entropy is increasing. It's becoming more disorderly. So there's a positive delta S of the system. Now I'm going to tell you that this is an endothermic process here. So if it's endothermic, it's absorbing heat, and so that means that heat must be moving from the surroundings into the system, which means that we have a negative delta S of surroundings. So similar to the last example. What's the delta S total? Well, this system is not at equilibrium, so it must be positive or negative. I'm going to make the assumption that this system will spontaneously move in the forward direction and dissolve, even if it's only slightly. And so since it's spontaneous in the forward direction, then we could say that the delta S total is greater than 0. If we were to be told that it's spontaneous in the reverse direction, then we would say the delta S total is less than 0. For an exothermic process, heat exits the system and enters the surroundings. Heat entering the surroundings increases the temperature of the surroundings, causing an increase in disorder. So the delta S surroundings would be greater than 0. And this is corresponding to the above pictures. All right, let's look at example 19.21. Determine the sign of delta S of the system, delta S of the surroundings, and delta S total for this process at 1 atmosphere of pressure. So here's our system. First, what's the delta S of the system? Well, it's moving from a solid phase to the liquid phase, so the system is becoming more disorderly. So I would say that we have a delta S that is greater than 0 or positive. All right, now consider that to move from solid to liquid, the process has to be endothermic. And endothermic means heat is moving from the surroundings into the system. So that means our delta S of surroundings is losing heat, and so it's negative. So this is less than 0 or negative. So here we only care about, is it an endothermic process or an exothermic process? Endo, the delta S surroundings is negative. Exothermic, the delta S surroundings is going to be positive. All right, what about the delta S total? Well, the question is, which direction? Is it spontaneous or is it at equilibrium? So let's take a look. We're told the temperature is 25 degrees Celsius. So it's not going through a phase change, because if it were freezing or melting, the temperature would have to be 0 degrees Celsius, which is the normal freezing point or melting point for water. So because it's at 25 degrees Celsius, it must spontaneously be melting and changing from the solid phase to the liquid phase. So the forward reaction is spontaneous forward, which means the delta S total must be a positive value or greater than 0. And so this would be our answer for this particular question. Now let's look at example 19.22. Determine the sign of the delta S system, delta S surroundings, and the delta S total for this process at 1 atmosphere. By the way, they tell you 1 atmosphere because that's considered the normal pressure, which means you're dealing with a normal, possibly boiling point or melting point, etc. They tell you the reaction is taking place under conditions where it is spontaneous. So this is spontaneous in the forward direction, which is going to tell me what my delta S total is. It's spontaneous forward, so delta S total is greater than 0 or positive. Okay, we are told, well, let's look at the system. We have 2 plus 1 is 3 moles of gas, and it yields 2 moles of gas as the products. So the system is becoming more orderly or organized. And so that means our delta S of the system must be less than 0 or a negative value because it's becoming more organized. Finally, if we look here, delta H's that are negative means we have an exothermic process. And so because it's exothermic, the heat is moving from the system out into the surroundings, which means that my delta S of the surroundings must be a positive value. So this is going to be greater than 0 or a positive value.